Okay, hello and welcome to our next unit on circuits and DC instruments. In this one, or in this part, we're going to be doing an equivalent resistance example that is more complicated than the ones we did in the last part. So without further ado, here is the circuit. I affectionately call this guy the Beast. He's very complicated looking. He's got a lot going on. We are told the battery down there at the bottom is 12 volts, and we're told the resistances of all of the resistors. Part of the problem with this circuit is it is confusing as it is drawn where the connections are. So the first thing that I think is helpful for this circuit is to redraw it. So first I'm going to redraw it as it was on the previous page. To the best of my ability. Okay, this was A, B, C. Make sure I get that right, yes. Resistor D, E, and F, and our battery at the bottom. And maybe you can just look at this and say, I see the first series and parallel combination on this one. But maybe not. So it's helpful to just rearrange it a little bit. So here is E and F. And now I'm going to stretch up a little bit. That's C and that's D. So now if we compare, we come out of this junction and we have three options. I haven't drawn one of them yet, but one of the options is we can go through E. The other one is we can go through C and come down through D. So if I look at that same junction right here, I can go through C or I can come down through D. The third option from this point is to go up and around and then down through D. Up and around takes me through both A and B. So now I think it is much easier to see the various connections that we have in this circuit. We can see that A and B are in series. That series combination is in parallel with C. All three of those are in series with D. This whole thing here is in parallel with E, and then all of that is in series with F. Okay, so we're going to go through this step by step. At each step, we're going to redraw the circuit and show what we're combining and do the calculations. One thing that I will say is for the calculations for the circuit, I made an Excel spreadsheet. So while the numbers that I write on the slides here as we go along may be rounded, when I was doing the actual calculations, they were not because they were in the Excel spreadsheet. And so you may get some round off error that I do not if you go through it. Okay, so step one, we look at this and we see A and B are in series with each other. So we're going to make a little step-by-step instruction for ourselves. So A and B are in series. And I am really sorry, but as we go, you will see that my resistors are going to become worse and worse. So that's C, this is D, and now up above where we used to have two resistors, we're only going to have one. And I'm going to call this resistor S1 for, it's our first series combination. And I can find the value of that resistor by adding the resistance of A to the resistance of B. On the first slide, A was given as 10 ohms and B was given as 15 ohms. So our series 1 has a value of 25 ohms. Now, the goal of this is to find the current through each resistor and the voltage dropped or the voltage used by each resistor. At this point, we can't determine those numbers, but we can set ourselves up for determining them. Okay. We know that this is a series combination. So whatever current flows through this combination, so the current through series 1, has to equal the current through resistor A, which has to equal the current through resistor B, because they're all in series. So as soon as I get IS1, I've got 2 of my numbers. So we're going to leave ourselves a big old blank, and we'll fill in the blank later. I can also find the potential by resistor A by taking the current through A times the resistance of A. Again, fill in the blank. And for B, it's IB times RB. And again, fill in the blank. I can't find these numbers yet, but I will be able to come back and fill them in. Okay, so step 2. Step 2 is I'm going to take RS1 and RC and combine them in parallel. So when I redraw my circuit, try to be good about my resistors here. This is E, this is F. I'm going to have one resistor here and one there. This is, that was supposed to be just a D, but it turned into an RD, so we'll go with it. And then this is the parallel combination of RS1 and C, which since it's our first parallel combination, I'm going to call it R parallel 1. And 1 over R parallel 1 will equal 1 over RS, ooh, that's an S, S1 plus 1 over RC, which is 1 over 25 ohms plus 1 over RC was 20 ohms. And that results, notice I've flipped it over, so this line is 1 over R parallel 1, and then my answer here is 11.11 ohms. Okay, so this is where the round off portion of the answers come in. Now, just like we did in the last part, and I guess I should write my heading here. Okay, now just like we did in the last part, I'm going to think in advance of what's going on here. So if I think about the current, it can go through C or it could go through RS1, but those are filling the same niche in the circuit. So whatever voltage is used by C has to be the voltage used by RS1, that combination altogether, because they're in parallel. So now I'm going to say that the voltage for the parallel 1 combination is going to equal the voltage for series 1 combination, which will equal the voltage due to C. And again, I don't know this number, but I can find it. Okay. And I can find that the current through series 1 will be the voltage through series 1 divided by the series 1 resistance. And the current through C will be the voltage across C divided by RC. Again, I can't fill in these numbers yet, but I will. Okay, so now before we go to the next slide, let's look and see. Our next combination is our parallel 1 and D in series. So our next combination, step 3, is R parallel 1 and D in series. And when I draw the circuit here, this is E, this is F. and this is going to be R series 2, where it is the series combination of R parallel 1 and RD. Okay. Because this is in series, R series 2 will equal R parallel 1 plus RD. R parallel 1 was 11.11 ohms. RD, according to the first slide, is a 10 ohm resistor. So this is 21.11 ohms, and that is our value of R series 2. Okay. Just like our previous series example, because it's in series, the current through I series 2 has to equal the current through the parallel 1 combination, which has to equal the current through D. So whatever that number is, we will find it. Okay. And V parallel 1 will equal I parallel 1 times R parallel 1. And VD will equal ID times RD. Okay, next step. So step 4. If we look, we can see R series 2 and E are in parallel. So again, redrawing the circuit. Ooh, I missed F. Here we go. We'll just put it in. This is going to be parallel 2. Look at how simple our circuit is becoming. We're down to 2 resistors. Okay, first things first, calculating the resistance of R parallel 2 will be RS2 plus 1 over RE, which is 1 over 21.11 ohms, plus RE on the first slide is given as a 15 ohm resistor. Okay, that equals 1 over R parallel 2. So if you add them properly and inverse when you need to, you get R parallel 2 is 8.77 ohms. But this is in parallel. So parallel combinations have to fill the same spots in the circuit. So V parallel 2 has to equal the voltage through series 2, which equals the voltage across E, and then IS2 will equal VS2 divided by RS2, and IE will equal VE divided by RE. Okay, it is, I hope, very, very obvious at this point what the next combination is. We have 2 resistors and they are in series. So step 5. R parallel 2 and F in series. And that combines us down to a single resistor. Oop, that should be an S. So that's R series 3. R series 3 will equal R parallel 2 plus RF. R parallel 2 we just found at 8.77 ohms. RF on the first slide is given as a 20 ohm resistor. So this is a 28.77 ohms. Okay. That number, 28.77 ohms, is the equivalent resistance for that circuit. So what does that mean? That means I could take the 6 resistors that we originally had, A through F, and replace them with a single 28.77 ohm resistor, and the behavior of the battery would be the same. Whatever current it produces would still be the same current it produces. Okay, now that I know the equivalent resistance for the entire let's try again. Now that I know the equivalent resistance for the entire circuit, I can use the fact that I have a 12-volt battery and the equivalent resistance to find the current produced by the battery. So the current produced by the battery will equal the battery voltage divided by R series 3. So that's 12 volts divided by 28.77 ohms. And that equals 0.42 amps. So the battery has to produce 0.42 amps. All 0.42 amps has to go through this series combination. So now I can say that the current through series 3 has to equal the current through RP2, which has to equal the current through F, again, because they're in series. All of this has to equal the current from the battery because it only has one path. Okay, we have to go through there. If I back up a slide, I'm also saying that that's equivalent to me having to go through here. There's only one path. Okay. And now I can find, hold on, yes. V parallel 2 will equal I parallel to R parallel 2, which is 0.42 amps times 28.77 ohms. And that works out to be, I'm sorry, I wrote in the wrong resistance there. R parallel 2 was not 28.77, it was 8.77. I plugged in R series 3, so let's get rid of that 20 there. Okay, and that works out to be 3.66 volts, and VF will equal IF times RF, and that'll equal 0.42 amps times the resistance of F, which we can see is 20 ohms, and that works out to be 8.34 volts. Okay. So now look at what I know. I know the equivalent resistance for the entire circuit. I also know the current through F, and I'm going to write it over here. This is the voltage dropped across F. The other thing to notice is if I take 8.34 and add 3.66 to it, that gives me back my 12 volts, which has to be the case because whatever the battery provides, the circuit has to use. It's a nice check of our math. Okay, the other thing we know here is we know V parallel 2. We know it's 3.66 volts. So when I go back a slide, I can now plug in this number, 3.66 volts, because there's my V parallel 2. Okay. That has to equal, as we've discussed, V series 2 divided by R series 2, which is 0.17 amps. That's 3.66 volts. Divided by R series 2, which is 21.11 ohms, or you can look at it up here. And IE will be 3.66 volts divided by the resistance of E, which is 15 ohms, and that works out to be 0.24 amps. And notice, we have, I'm going to come up here, at this point, coming into the junction, 0.42 amps, and then it breaks. The current through series 2 going around this way is 0.17 amps. The current going through E is 0.24. And if I take 0.24 and add 0.17, I get, within round-off error, 0.42 amps. Okay, now we can move back again. I can see down here that the current through series 2 is 0.17 amps. So I'm going to take this number and plug it in up here. I can now find the voltage dropped across our parallel 1 combination and D. Parallel 1, V parallel 1 will be I parallel 1, which is 0.17 amps, times R parallel 1, which is 11.11 ohms. And that equals 1.93 volts. Similarly, the voltage drop across resistor D is the current through D times the resistance of D, which is 0.17 amps, times 10 ohms, which is 1.73 volts. Again, just rounding a little bit different. All of this is calculated in Excel in my world. Okay. Moving back once more, I'm going to take V parallel 1, 1.93 volts, and plug it in for V parallel 1. Okay. That has to equal the voltage used by series 1 and the voltage of C. So I can find the current through the series 1 combination by taking the voltage divided by the resistance. So 1.93 volts divided by R series 1, which is 25. Which is 0.077 amps. And similarly for the current through C, I can take VC, which is 1.93 volts, divide by RC, which is 20 ohms. 1.93 divided by 20 is 0.097 amps. And lastly, we'll make it all the way back to the end. We're going to take IS1 and move it back. So I see that the current through series 1 is 0.077 amps. So now I can find the voltage drop across resistor A, so 0.077 amps times 10 ohms is 0.77 volts. And similarly for VB is going to be 0.077 amps times 15 ohms, which is 1.16 volts. And if you look at the original questions that we were asked, what is the equivalent resistance? We've done that. What is the current through each resistor? We've done that. And the voltage drop across each resistor, we've done that too. So let's just go through and kind of box in where all those pieces are. There's A, B, and C. Here is D, E, and F is right there. Okay, this completes the beast. On a quiz, I would not ask you anything this complicated. It is a great teaching circuit though, because you do the same process, combining in series, combining in parallel, multiple times, and can kind of get used to what happens for a series combination and a parallel combination. In the next unit, we're going to be introducing a different means of analyzing circuits, one that is valid for slightly more complex circuits.